All right, so let's take a look at the turtle panel. This is the beginnings of the implementation of the view. Right? The view, as we saw earlier, the controller, after having parsed the input from from our input field, it processes the command, it instantiates the correct command pattern, and then executes it. Right? It says go, right? And each one of those commands updates the model. Once the model is updated, it can turn around and tell the view. It says, "Hey view, these are the new lines. Here's the new position of the model of the turtle. So somewhere we need to render this, and we haven't looked at that. So that's going to be the responsibility of the turtle panel, right? The turtle panel is going to be implemented with the use of a new swing component called the Jpal. The Jpal is a generic container, right, that allows you to it's very useful for containing multiple buttons, for containing multiple other components. It's not a full-blown window, right, that is represented on an actual window on the screen. But certainly it allows you to break up that window into multiple subcomponents, right? Very generic components. So it's a component that can contain other components. Right? But in particular, it also allows you to draw on it, right? Perhaps put a canvas. Any component, all swing components can be drawn on, right? So you can draw on the button, or you can draw on an input field. Not that you would, but Jpanel is generic enough, right, that it's not representing anything, right? We can leave it blank, and then just use its inherited callback functions, right? Callback methods to actually draw on it. It's going to contain a couple of things in there. In particular, it's going to contain the list of lines that it needs to render on the canvas. It'll have the position of the turtle, the heading, the center of where the turtle is being rendered. And it'll do some simple math to render the turtle looking at depending on the heading, right? It'll render it either looking left, right, up, down, or any degree of the particular degree angle. It has some high level methods that can be called from the controller. So the controller can say, hey, here's the new model. Here's the new turtle where it is, right? So, and here are the lines that you need to draw. The view is actually going to proxy this, right? So the controller is going to send it to the view is going to send it to the panel, and the panel is going to render this, right? So there's a little bit of indirection in there. So let's look at the rendering. Right? So in the constructor, we're saying super. So update, initialize yourself like you would necessarily. We update, we initialize all the variables that we need internally for representing the lines, for representing the positions. We initialize the position of the turtle as 0, heading 0. And this is going to be overwritten by the model, right? Whenever we see something from the model, we're going to say, the model says that we should look at some other direction, right? We should be positioned at some other place, right, other than 0. Also, we initialize the background of the screen to be white. Notice it's this set background. That's a function we're inheriting from Jpanel. So Jpanel has tons of graphical methods that we inherited, and one of them is set background. You can also set the foreground if you want to draw on a particular line, a particular color. You can set fonts. You can set all sorts of graphic-related methods that we inherit from Jpanel. Another method that we inherit from Jpanel is a paint component. Okay, this is as the component is added to the screen and as the screen is rendered in a window, each component is invoked this function, paint component, and then each component knows what to paint in there, right? So the button knows to paint, rounded corners, a little background, center the text in the middle, with a foreground of white, whatever, right? Each component knows how to render itself. But this is a Jpanel, right? So Jpanel by default doesn't render anything, right? It only knows how to render things that are inside of it. Right? If it contains multiple buttons, it will iterate over the buttons, telling each button to render themselves, right? But we can override the paint component and says, no, this is what I want to render. Right? When you call my paint component, this is what I want to render. And and as an argument, we're passed a graphic context, saying what is that we want to. This is your pen, your pencil, your pen, so you can draw on the panel. And we pass it to you, and the graphics is a variable can be casted to either 2D or 3D, so you can paint with X, Y, Z or just X, Y. Here we're just sticking to two-dimensional drawings. One of the things we need to never forget is to first call our parents' paint component, right? Because our parent paint component does a couple of things. Set up the background. Erase the content. Does some initial housework. Before you get to actually render the content, right? So first call paint component. We're getting the two-dimensional graphics context, and here we have all the really low level commands to actually draw on the screen. Right? We can draw lines, point. We can transform and rotate the context. We can flip the context, right? Which we're going to need to do because the commands that we're sending, we assume that it's a Cartesian location where we have the 0 and the X and Y are 0 on the bottom left. But it turns out that in Swing, 0, 0 is actually top left as opposed to bottom left. And we think of Y as incrementing up, whereas in Swing, Y increments down. So that we can flip the world for the human being to understand that this is a regular Cartesian graph. We are gonna use a transformation, a transform, where we're gonna leave the X untouched, right? But whereas the Y, notice the -1 there in the transformation, we're gonna flip the Y, right? So that any incrementing in Y position, it'll go up as opposed to down. Okay. So that's what the transformation is going to allow us to do. Flip the coordinate system, and then presumably we're going to render this when somebody's going to call the refresh, right? The refresh is going to be invoked by the view and say, okay, well, it's time to re-render yourself, and our re-rendering it will be to blank the screen. And put the background as white, and then start drawing, right? And the things that we want to draw are the turtle and the lines, right? That's the two things we need to render. The lines, presumably somebody sent us an array of lines, an array list of lines. We're just going to iterate over them, looking for the X and Y for the start, and then the X, Y for the end, and we just draw a straight line using the default color black. Actually, no, we did set the color to black. We can change it to any color we want. Also, the default width of these lines are 1 pixel, but we can change that. We can change this to different strokes. If the width, you can change the width of the line. You can change the pattern of the line. If you want to, by default, it's a solid line, but you can make it dotted, dashed, whatever. There's a whole bunch of. Also, the ends you can change so that instead of being you can taper them, right, so that they're rounded at the end of the line. So there's quite a bit of customization that Swing allows you to do with drawing lines and circles and whatnot. So we're iterating over the lines. We're drawing each line. Once the line is drawn, we're going to turn our attention to the turtle. We want to point the turtle in the right direction depending on the turn. Right, if it's 90 degrees, we're pointing to the right. If it's if it's 0, we're pointing to the right. If it's 90, we're pointing up. If it's 180, we're pointing left, or 360, we're pointing down. So we're going to transform the heading. The heading is in degrees. We're going to convert it into radians, so that we can do some trigonometric calculations here, and we're going to use we're going to transform. Right, and rotate the turtle based on the radians. So there's a graphics 2D rotate allows you to rotate the drawing of the turtle And here we're drawing as three different ovals, three different circles, so that we can distinctly know where the head is of the turtle is. So that there'd be like a yellow, there'd be a red head of the turtle, so that we can see where it's pointing to. Right, as it rotates, we can see where it's heading. So this doesn't actually render until where's the paint? Is there no paint? So typically there's a very low level function method. I guess I don't have it here, which is the repaint method, which is actually tells the panel to actually paint. Right? Maybe it's in the view. Probably it's already in the view. Yeah. And it tells a component, hey component, this would be a really good time to refresh yourself, right? Just erase everything you had, right, and re-render yourself, right? It doesn't actually happen the time you call it. It's only a suggestion. The rendering engine is free to choose when it actually paints, right? It's a multi-threaded process, right? It might have many components that it needs to update depending on the events that are being flowing back and forth. But it's like when you do garbage collection, right? You can't actually force the virtual machine to do garbage collection, but you could tell the underlying virtual machine that this would be a great time to do garbage collection, right? And then the infrastructure is free to actually do it or not, or delegate it, or postpone it to several milliseconds later. So the paint component is where we put our logic for rendering, but the actual repainting is kicked off by repaint, which I think we have it in the view. We'll look at it in a minute.